It's not recording. Okay, fine. Now we'll we have got the difference between the years, and we've got the difference between the population censuses, which is 12,500. Now the annual increase, as the annual increment, will be this 12,500 divided by this 10. This 12,500 divided by 10. And this will give you 1,250 persons per year. 1,250 persons per year. Now that we have our value for K, we have our value for the total population. 1,000. So we're expected to find the year. That's what the question says. It says find a year a population will reach a target of 60,000. So if you check that formula, the step 2 is set up the projection equation from 2015. And our base population is this value we got from the census of 2015. This value we got from the census of 2015 is 42,500. Now, when you substitute, your P subscript T now will be 60,000. So, this P subscript population as 42,500. That's your base population. Plus this your K, which we computed to be 1,250 persons per year, which is here. So all we're required to do is just to make T. That's the time in the subject of the formula. And we already have 60, which is given the question. The base population is already given. We calculated our value for K. Now we're expected to find T. Now, ladies and gentlemen, how we got 17,500 is from the fact that we subtracted 42,500 on both sides. If you subtract 42,000, this 42,500 on both sides, we'll have 17,500 equal 1,250. And in this case again, you divide both sides by 1,250. If you do that, you have 14. Now, we are asked, when will the population hit 60,000? When will the population hit 60,000? And you are aware of the fact that our last census was conducted in 2015 based on this question. So you will add this 14 plus the 2015 to know the year that the population will reach 60,000. Now, step 4 is to convert it to a year. And the year is equal to 2015 plus 2014 that we got in here, which is 2029. So your conclusion will be that the population will hit the target of 60,000 in the year 2029. That will be your conclusion. The population will hit a target of 60,000 in the year 2029. Any question? Any question? If you don't have question, I can proceed, isn't it?
Yes, sir, you can proceed.
Okay, that's fine. Now, this is the assignment I gave you guys yesterday. I said predict the population for the year 31 and 2036 from the following population data. We have the first row to be the year, the second row is the population. So for 1991, we have 80,000. For 2001, we have 95,000. For 2011, we have 112,000. For 2021, we have 131,000. For 2026, we have 142,000. Now, gentlemen and ladies, I'm going to just take random response so that I can. Madam Agatha Chukuma, what is your predicted population for 2031?
2031, sir, I got 151,000, sir. 151,000, sir.
And complete it now, complete it. Just 151,000.
That's what's predicted for the population growth in 2031.
Exactly 151,000.
Yes, sir.
Well, yes, it's 151, but something is supposed to be added.
I actually rounded up.
151,125.
I rounded up to the nearest distinct thing.
Inusa.
Sir?
What is your projected population for 2031?
151,125.
125.
Yes, sir.
Francis. What is your projected population for 2031? She is not there. Simeon.
Yes, sir.
For me, what is your projected population for 2031?
Yes, it's 151,125, sir.
125.
Yes, sir.
How about for 2036?
160,250.
How comes me I have for 2031, I have 151,700. Why for 2036, I have 161,400.
So, I mean, we will check the
I have
process
151. I have 151. I have 151,700. And for 2031, I have 161,400.
So check your calculator, maybe it malfunction. Yes. Yes.
No, I don't think so.
But sir, that is what we got to 160,250.
So maybe we'll run through the process so that you will hear.
No problem. How about your K? Where we'll get this thing right. How about your K? The average K, what did you get as average K?
My average K is 1,825.
That's where the problem is. My average K is 1,940.
So maybe we'll take the K one by one so that we'll see where the difference is coming.
No problem. We'll check that later. So that let's have progress in the class.
It's okay. Because at least we have gotten this one. So
now it could be that maybe you are rounding up too early. When I'm doing my calculation, I don't round up immediately. It's at the end of the results, at the end of my answers that I round up. If you round up from the beginning, you have issue. You will not get it.
So like this one is not even having fractions. This one is not even having any fractions.
No problem. When I check what you are solving, I'll know where the problem is.
It's okay, sir.
Because my calculator has never failed me. It's okay.
Sir,
Now let's look at
maybe it's
geometric.
just a parallel. Okay.
Geometric growth method. If population grows at a constant percentage rate R per year, where P naught as usual is the base year population, R is the annual growth rate as a decimal, age at 3% is equal to 0.03. And how you get this 0.03 is 3 divided by 100. You have this. You have this. T is the number of years after the base year. T is the number of years after the base year. And P subscript T is the population after T years. Population after T years. Now, if you have two census populations, P1 and P2, that's P subscript 1, P separated by N years, then your R is equal to P2 divided by P1, bracket open and close, raised to the power 1 over N minus 1. So this is just a brief introduction. Now let's take a practical example to see how this is done. As an example, 1, project population when the annual growth rate is given. A town has a population of 250,000 in 2010. It grows at 3% per year. Find the population in 2025. A town has a population of 22,000 and 50,000 in 2010. When this census was conducted in 2010, the town had this population, 250,000. And it was observed that the population grows at 3% per year. That is between 2010 and 2015, the population was growing 3% per year. Find the population in 2025. So the very first thing we're going to do is to identify parameters. Our P naught as given in the question is 250,000. Our R as defined in our parameters is 3%, which is equals to 0.03. And our T is equal to, T is normally the difference between the years. The last census was conducted in 2010. According to this question, it's in 2010, and you're expected to project the population for 2025. So your T will be the difference between the years, in this case, which is 2025 minus 2010, which will give you 15. Now, step 2 is to apply geometric formula. So, and the formula we're using for the geometric is here. So all we have to do is we'll apply the geometric formula, which is 250 into 1 plus 0.03 raised to the power 15. I didn't write this formula here. Don't worry, I will send it to you guys. It's 250. As you can see, there's a mistake here. There's supposed to be 10 here. Into 1 plus 0.03. The T. The formula is PT is equals to P naught into 1 plus R raised to the power T. So this is 250. If you add 1 plus 0.03, you have 1.03 raised to the power 15. So this your 250 is here times here now. This 1.55555, this long figure here. How you will do this is 1.03 times 1.03 in 15 places. Or if you have a very good functional calculator, what you do is 1.03 raised to the power 15. So you can see how my figures are lengthy. You can see how I have 1.5579674166. You from here, if you truncate, if your result stops 7, okay, if you want to truncate it here, obviously you will have 1.6000. You can see that your result will be different from mine, isn't it? See how my own is lengthy. Maybe those of you who did the other guy, you just truncated at some points here. But you see how my figures are lengthy here. So if you truncate here, we will not have the same result. So this is 389,492. So the projected population in 2015, in 2025 is 398,492. I'm going to send this formula to you. The formula is P subscript T is equal to P subscript naught into 1 plus R raised to the power T. So that's the formula. And here, please, there's 1 0 here. As you can see, 250 have been consistent here, 250,000, 250,000 here. There's a 0 that is missing here. So on this question, any question on this solution?
So okay, move ahead.
We go to example 2, right? Can you hear me?
You can hear you, sir.
Okay, example 2. Find the growth rate from 2 censuses. Then project. A city had 120 persons in 2006 when the census was conducted. Why in the 2016 census, the head count gave rise to 170,000 persons. Estimate the annual growth rate, R, then project the population for 2026. Remember, I told you that if you have 2 population and you are to find the growth rate, this is the formula you use. R is equal to the later population all over the earlier population, bracket open and close, raised to the power 1 all over n minus 1. So that's the formula we're going to use. And as you know, the 2 population, this is your P2. 2016 is your P2. 2006 is your P1. So the first to do is to find the time gap between 2016 and 2006. So this is 10. Now the next thing we're required to do is to compute the growth rate, which is R. And our R is equal to P2 all over P1, bracket open and close, raised to the power 1 all over n minus 1. In this case, our P2, according to the 2016 census, is 170,000, and our P1, according to the 2006 census, is 120,000 persons. So our n is 10 already, and the formula says 1 all over n. So I'll put the n there, minus 1. This is equal to, if you cancel out these 3 zeros, you'll be left with 170. all over 120, bracket open and close, raised to the power 1 all over 10 minus 1 is equal to, if you perform this algebraic simplification, 170 over 120, you have 1.41666667. And 1 all over 10 is the same thing as saying 0.1 minus 1. If you do this computation, you will have approximately 0.0354436. So your R now would be approximately 3.54436% per year. How we got this, if it's percentage, we'll multiply by 100, isn't it? That's how we got this. So, Madam Patience cannot truncate it here to have 3.55 here to 2 dp. So, but I keep telling people, if you truncate at this point, it will affect your subsequent results. But in the question, I'm going to guide you that all your computation, if it is to 2 dp, I will tell you. If it is to 4 dp, I will tell you, so that we'll have the same result. I will not just leave it open-ended. Some persons will be working with 6 decimal places, some will be working with 4 decimal places, some will be working with 2 decimal places, some day one, they will just round everything up. No. I will ensure that we work with the same decimal places so that we arrive at the same results. So the next step is to project the population from 2016 to 2026. And here T is equals to 2016 minus 2026 minus 2016. This will give you 10 years between 2016 and 2026. Will give us 10 years. So we want to project the population now. And I told you the formula is P naught into 1 plus R bracket close raised to the power T. So our base population is 170, that's our P naught into 1 plus R. And we computed R is here. So what we'll do now is you carry this value of R, 1 plus the value of R, and then substitute it. So you go and substitute the value of R, then you observe that you have 170 into 1 plus, into 1.0354435, bracket close, raised to the power 10. And this is equal to 170 times this value, which is equals to this. So since we can't have human beings in fractions, I've never heard we'll have half human beings, so we'll approximate. And if you approximate, we'll have the projected population in 2026 to be approximately 240,833 persons. Any question?
Doctor, good morning. Maybe the fraction will represent pregnant women.
The truth is that we have never had half human being. Somebody will have only, they will divide you into 2. You can't talk now, you'll be a dead person. So we always have human beings that are full. So we can't have half. So example 3, so that we'll round up this class and do something else. You are required to find a year. You are required to find the year a population will reach a target. In this case, you are required to solve for T. So a district has an initial population of 80,000 in 2020 and grows at 4% per year. And grows at 4% per year. When will it reach 100,000? When? We'll find out shortly. So step 1 is to write the model as follows. P of t is equal to P naught. Here, I did something here. It's 1 plus R. I know this R here is 0.04, isn't it? 4% is equal to 0.04. So that your 1 plus 0.04 will give you 1.04 raised to the power t. So the P of t, that's our total population, is 100,000. So we're going to have 100,000 is equal to 80,000, 1.04 raised to the power t. Please, when you are doing your computation, never you say 80,000 times 1.04. It should never happen. You get a wrong answer. So in this case, we divide, we're trying to look for t. We're trying to look for t. So you divide both sides by 80,000. And if you do that, right here by 80,000, here by 80,000, this 80,000 will cancel out. So here on the left-hand side, you have 100,000 over 80,000. Even here, 4 zeros will cancel out. This last 3 will cancel this last 3. This one here will cancel this one here. So you'll be left with 10 all over 8. 2 there, 4, 2 there, 5. So 5 all over 4 will give us, or if you want to say 10 divided by 8, that will give us 1.25 equal to 1.04 raised to the power t. Now, ladies and gentlemen, from here, the third law of logarithm says if you have log a raised to the power n base m, the end result is equal to n log a base m. In this case, I'm taking log on both sides. I'm taking the log on both sides. If you take log on both sides, this is what you're going to have. The idea here is to get the value of t. And if you do that, you take log on both sides and make t the subject of the formula, you will have to lean 1.25 all over log 1.04, which is approximately, if you check the log of this, if you check the log of that, is that, which is approximately this. Now, if you convert to a calendar year, remember that the last census was conducted in 2020. So you add it with these 5 years, you have 2025.6894. Now watch the way I've drafted my conclusion. After the population will reach 100,000 around late 2025, and by whole year counting, it will be in 2026. If you round it up here, your conclusion will be that the population will reach 100,000 around 6. But if you leave it the way it is like this, our conclusion will be that the population will reach 100,000 around late 2025. But if you round it up to a whole number, we'll conclude that our population will reach 100,000 around 2026. Thank you. Any question before we move to something else?
So
If
will
there are
this
no
one
questions,
will this one be compulsory that day on the day of exam?
which one?
This particular geometric this thing you are solving, this formula you are doing now.
How do you know that it's coming out in the exam?
No,
It's
we're just
part of your
asking because
teaching
this
now.
one did not enter.
No, Madam Agatha, you told me you will go and go through. You are compiling your questions. That's what you told me. That you have a lot of questions for me. You are compiling them. By the time you
I
read
want to
and know
start
very
now.
well,
I want to start now because this one did not enter, sir.
where did it not enter? Tell me.
From this indices place, I don't understand what happened there.
No, let
The
me
law
go
where
back.
you apply the laws of indices.
Yeah, I will show you. Don't worry.
Okay, sir.
Just if I write on paper, you see. The third law of logarithm says log a raised to the power n base m is equal to n log a base m. For center, wait and come. 1.25 is equal to 1.04 raised to the power t. If I take log on both sides, so I have 1.25 equal to log 1.04 raised to the power t. So I have log 1.25 equal to t log 1.04. So if I divide both sides by 1.25, now watch. Don't even know whether you can see. Can you see?
Yes, sir.
Can you see it? Look at it.
It's
See
faint,
how I
sir.
broke it down. Eh?
It's faint. You can't see it very well.
Okay,
Can't
fine.
see it well.
I will scan this and send to you so that you can look from there, then you understand what's here.
Thank you,
Okay,
sir.
sir. Thank you,
Thank you.
sir.
This summing is very, very detailed. Very, very detailed, very, very fine. Okay, that's something else. Because Madam said this one did not enter. It must enter. Um, Next, we'll do median, and mode. The one we're doing now is from an ungrouped data. We have data that is grouped. We have data that are not grouped. So, mean, median, and mode are measures of central tendencies or averages and form the basis of statistics. There's a small note I have on mean, median, and mode. I think if I explain stuff, you can get it. Mean is the average in a set of distribution. To calculate mean of a set of data, you add up all the data, divide by the number of data you have. While median is the value that appears in the middle of a distribution time you arrange in either an ascending or decreasing order, while the mode is the one that appears most frequently in set of distribution. The one that appears most frequently is the mode. While range, if you've heard of range is the difference between the highest score and lowest score in a set of distributions. To calculate the average mean of a set of data, we must first add up. That's sum. When we say add up, we mean sum. All of the data values, and then divide the result by the number of values n. So since this is a summation sign, since this is the symbol used to indicate values are summed, we call it sigma. In Greek, we call it sigma. In English, we call it summation. We obtain the following formula for the mean. X bar mathematically is what we use in representing mean. X bar. So sum X simply means you sum all the values in a set of distribution, you divide it by the number of values in that distribution. For example, I have 2, 3, and 5. I only have 3 values there. So I will sum 2, 3, 5. I will divide by 3 because I only have 3 values in that distribution. 3 set of numbers in that distribution. Let's take an example quickly. Example, find the mean of, you're required to find the mean of 6, 8, 11, 5, 2, 9, 7, 8. Altogether, we have 1, 2, 3, 4, 5, 6, 7, 8. We have 8 set of values in this distribution. So the mean will be adding all these values up, we divide by n. In this case, you don't need to arrange it in an ascending or descending order. Just add and divide by the number of values in this distribution. In this case, the number we have here is only 8. So that's why we're adding 6 plus 8 plus 11 plus 5 plus 2 plus 9 plus 7 plus 8. All over 8. All over 8. So if you add this up, you will have 56 over 8. When you divide this, you have 7. Is there any issue finding the mean?
No,
No,
sir.
sir.
No, sir.
No, sir.
For now, until we see
No,
the
sir.
conclusive one.
There's no issue, sir.
Okay. Median. Median. This person calling me now. Sorry, just a minute. Let me answer this call. Okay, sorry for the break in transmission. The median value of a set of data is the middle value of the ordered data. The median value of a set of data is the median value of the ordered data. When we mean ordered data, is that or you find the median, you will arrange it in an ascending or descending order. You know the meaning of ascending or descending. Either you arrange it from lowest to highest is ascending. From highest to lowest is descending. I hope you can hear very well now.
Yes, sir.
Yes,
Can
sir.
hear you.
Very well, sir.
So, worked example, we are to find the median of the following. You have 11, 4, 9, 7, 10, 5, 6. Ordering the data gives, when I say ordering data, we mean arranging the data from either highest to lowest or lowest to highest. In this case, we are arranging from lowest
Sir, no audio. I can't hear you.
Things has been disconnected again.
Hello, Simeon. Hello, Simeon.
Yes.
Simeon, how far?
Fine. Oh.
Abeg, no vex. See, I'll talk with you later, abeg. I'll call your line.
Thank you.
Yeah, ba.
I've heard
Hello.
you. I've heard you. I've heard you. Oga is back. Oh. I've heard you.
Okay.
The network is very bad. Let me share my screen again. Now, can you see the screen?
Yes, sir. Yes,
Okay,
sir.
fine.
See it.
So when you arrange the data from the lowest to highest or from the highest to lowest, you will observe that the median here is 7. So we say the middle value is 7. Now for the B part, we have a different scenario here. You are asked to find the median of the following set of values. And if you order this set of values from the lowest to the highest, you have this. You observe that this pair, because we have 1, 2, 3, 4, 5, 6, 7, 8. This is even. You know, in this case, we had 1, 2, 3, 4, 5, 6. The number here is odd. And when it is odd, the median comes out straightforward. But in this case, our set of values in this distribution is even because we have 8 of them. So we'll choose this pair as our median. And this is how to get the median. Now here, there's a middle pair. And the middle pair here is 2 and 2.5. So the median is between these two values. How do you find the median? You take the mean of them. And the mean of them is 2 plus 2.5. You add this up, 2 plus 2.5 divided by 2, you will get 2.25. So in general, the median is at the n plus 1 all over 2, n plus 1 all over 2th value. So if you have an odd number and you are asked to find the median, you just get the middle value. But if the set of distribution is even, if the set of distribution, the set of values, the set of scores in the distribution, if it is even, there will be a pair. For even numbers, you're going to have a pair. So when you have a pair, you will add those two pairs together and divide by 2 to get the median. Is there any challenge there? Inusa. Malam Inusa. He has gone. Freda.
No, sir, I've not gone, sir.
You don't understand?
Yes, sir. I'm here, sir.
Understand, sir. Let me just go.
Oche, any question?
What I wanted to ask, you already said it. Is
What did I say?
Explain. So no.
What did I say? Tell me what I said.
I wanted to pairing of the number. I wanted to ask you whether if a situation where the distributions are 8 or like the other ones are 7, like if it is 8, what do you do? But you already explained that you add the two middle numbers that are there.
Okay.
That are in that distribution. Okay. Add it and divide by that's n plus 1 divided by 2.
Fine, thank you. Yes. Now for the mode. This one, nobody is supposed to have issue here. The mode is the most frequently occurring number in a distribution, isn't it? The number that occurs most frequently is the mode. Well, here I said the modal value of a set of data is the most frequently occurring number, the one that appears most frequently. The one that appears most frequently. Now, from this worked example, find the mode for 2, 6, 9, 2, 6, 3, 9, 5, 6, 2, 6. Now, here it can be seen that the most frequently occurring value is 6 because there are 3 of them. Do you see any other value that is most frequently occurring apart from 3?
No, sir.
Okay. So mode for an ungrouped data, if you watch very well, this data is not grouped. A data that is grouped is all the data that you have, let's say 0 to 5, we have 6, 4 to 9, we have 7, something like that. That's what we call grouped data. Any question?
Yes, sir. There's a question here.
Okay.
Let's take this example you did for the mode. Let's say from this number distribution we have here. Let's say we don't have number 9, we have number 2. What do we take as the mode?
If you have what?
I said
I
from
didn't
this
get you very well.
example, from this example, we just
If I have what?
number distributions here. Let's say we don't have number 9. We have number 2. Let's say we take out the 9 and replace it by 2.
9 replaced
Yes,
by
let's
2.
take number 2. What will be the
It's
mode
very
now?
simple now. Listen up. It's very simple. If you replace by 2, how many? If you replace by 2, we have 3
You
2s
have
and
3
3
to
6, isn't
6.
it?
Yes.
The most frequently occurring numbers are 2 and 6.
Okay. So the mode mustn't be just one number. They can be
No.
2 or
They
6.
say the most frequently occurring number in a set of distribution. If you have 2, 4, 6, 4, 9, 4, the most frequently occurring number is the three of them. Steven, is that okay?
Okay, fine. Very clear, sir. Okay.
Now you have some exercises here which you can practice, and the answers are there. Can we make progress?
Sure. Let's
Yes,
go.
yes, sir.
Yes,
sir.
um, why is this thing not X? I want to open a new document. Now, let's look at variance and standard deviation. But before we do that, at some point I told you that range is the difference between the highest score and lowest score in the distribution. So that is my how will I put it now? That is by my own definition. The difference between the highest score and lowest score in a set of distribution, or the highest value and lowest value in a set of numbers. So by recall that range is the difference between the upper and lower limits of the data, which is the same thing we're saying. I don't like this definition. My definition is the difference between the highest value and lowest value in a set of distribution. So why this is important? It does have one major disadvantage. It does not describe the variation among the variables. Recall that range is the difference between the upper limit and lower limit of a set of data. Why this is important it does not have one major, it does have one major disadvantage, and it does not describe the variation among the variables. I'm trying to tell you how we're coming into variance and standard deviation. It is the shortcoming of range that gave rise to variance and standard deviation. That's what I'm just trying to tell you. So why this is important, it does have one major disadvantage. It does not describe the variation among the variables. For instance, both of these sets of data have the same range, yet their values are definitely different. Range is 8. Even here, the range is 8. Because why is the range 8 here? The range is 8 because the highest value here is 98. The lowest value here is 90. So the difference between 98 and 8. So the range is 8. Even in this set of values, the highest value here is 9. The lowest is 1. The difference between 9 and 1 is 8. So the range is 8. The range is therefore, by definition, the difference between the highest value and lowest value in a set of numbers or in a set of spots in a distribution or set of values in a distribution. Now, to better describe, I hope there's no problem about range.
No, sir.
No, sir.
No, sir.
To better describe the variation, we introduce two other measures of variation: variance and standard deviation. Now, variance is the square of the standard deviation. These measures tell us how much the actual values differ from the mean. The larger the standard deviation, the more spread out the values. The smaller the standard deviation, the less spread out the values. This measure is particularly helpful to teachers as they try to find whether their students' score on a certain test are closely related to the average score. What they are saying is that, especially these people in carrying out research in education, in other field of endeavors. Let me give example in the classroom setting, because I'm a teacher. If you want to know the deviation from the mean in a class, you deploy the use of standard deviation. You want to know how much the scores deviated from the mean of the class. You know, if you check your children's report sheet, even your own, when you were in primary, secondary school, you say the school will always write class average. That class average, once you know the class average, when parents look at their children's result, they'll say, what's the class average? The class average is 72. My child's score is 41. It's too far away from the class average. That's the deviation from the mean. That thing people are saying, you are talking about standard deviation, but you don't know. It's deviation from the mean. So if the mean of the class is 75 and your child score 90, you say, no, my child went far above the class average. That means it's super intelligent. At the moment the score is extremely low, it deviated from the mean too much. You have to work on your child. Your child's score deviated from the class average too wide. It's too wide, which is not good. So that's that about standard deviation. And how do you find it? How do you find it? To find the standard deviation of a set of values. To find the standard deviation of a set of values, first you find the mean of the data. You know how to find the mean now. You add all the set of values in that distribution. you divide by the number of values in that distribution. Next, you find the difference deviation between each of the scores and the mean. Square each deviation, sum the squares, dividing by 1 less than the number of values. Find the square root of the variance. That's the standard deviation. Now, note, in some books, the variance is found by dividing by n. In statistics, it is more useful to divide by n minus 1. This is not too clear. Let me explain to you. If you are dealing with a population, an entire population, you divide by n. But if you are dealing with sample of scores, just a sample, you are taking a sample from the total population, divide by n minus 1. That is why they say in statistics, it is more useful to divide by n minus 1, because in statistics, you take samples you take. By the time you finish your sampling, you take a sample, conduct the analysis, and you generalize. That's why we say in samples, you divide by n. The moment you are talking about a population, an entire population, you divide by only n. But if you are talking about a sample out of a population, you divide by n minus 1. That's the difference. In the exam, it will be specified anyway. If it's a sample, you'll be told. If it's a population, you'll be told. So all this grammar, can we take an example quickly to drive our point home, so that you can understand what we're talking about? Example, find the variance. Find the variance and standard deviation of the following scores on an exam. Now, you see this set of, it's not the entire scores in the class. It's just a sample of the scores. So, first we find the mean of the data. And the mean is adding up all these scores, divided by 6. Why are you dividing by 6? You are dividing by 6 because we have 1, 2, 3, 4, 5, 6. So you divide by 6, which is equal to 477 divided by 6, which is equal to 79.5. This is the mean. That's the class average. Now, this course here, there's a way I'm going to arrange this thing very well. I just want to use this one. I broke it down in pieces just to make you understand. All these things I'm doing, I'll put it in a one tabular form. But I want you to understand bit by bit. That's why I'm doing this. So this is your scores that you have here. This one here. This course 92, 95, 85, 80, 75, 50. I'll arrange it here. You have 92, 95, 85, 80, 75, 50. So here is x minus x bar. In the next class, I want to show you, I'll be using mathematical notation. This mean here is x bar. This score here, all these scores, x only x. So this column here is x minus x bar. So your x here is 92, this 92. Your x bar is 79. So here you have 95 minus your mean. This 85 minus your mean. 80 minus your mean. 75 minus your mean. 50 minus your mean. So this column is called x column. This column here is called x minus x bar. X minus x bar. So the difference now, this x minus x bar, this is the result. 92 minus 79.5 is this. 95 minus 75.5 is this. 85 minus 79.5 is this. 80 minus 79.5 is 0.5. 75 minus 79.7 minus 4.5. 50 minus 79.5 is minus 29.5. So next is to square. Next is to square. I will square all this. I want to square all this. That is, this column and this column, there's no difference. So x minus x bar. So the next column we'll create is x minus x bar squared. X minus x bar squared. So this is your difference here. This one's here. You square them now. And if you square them, you will have this. Then immediately you add it up. When you add it up, you have this. Formula I will give you in the afternoon is for variance is sum into x minus x bar square all over n minus 1 when it is for sample. Then when it is for population, divide by n. So we will divide by 6 minus 1, n minus 1. I think I typed this in somewhere neatly. I will show you in the afternoon. I will look for it and show it. Well, this is it. This is how to arrange it. Can you see?
Yes, I can see it.
If I will scan it, send on the platform. Now, you are still expected to find the mean now. We next find the mean of this sum, which is this, and it's this. When you divide by 5, you are dividing by 5 because it's n minus 1. So it's 263.5. So finally, we find the square root of this variance. And the square root is approximately 16 point. So I will scan this now neatly and send from the platform. I will scan it now and on the platform. This is from grouped data. I'll scan it now and send to the platform. So this is the formula for the standard deviation. S is equal to the square root of sum x minus x bar square all over n minus 1. This xi is xi because let me show you something. Xi because x1, this is x2, this is x3, or this is x. So we call it xi. Xi because we don't know the number in the distribution. In this case, we'll have 6 of them. So this is standard deviation and variance. Any question here? Ask your question before we move to the next thing. Any question?
Please, can you
No
scroll down?
question. We can move to the next.
Please, can you scroll down a bit?
Yeah.
Yeah, okay, fine. Okay, it's clear. I've seen what I wanted to say. It's fine. I wanted to know how we got 5 here, but I think it's from the formula.
This is from the formula.
Yeah.
n in is n minus 1.
N minus 1.
Um,
Yes, I've got.
uh-huh. This one is just scattered. I'm going to send you. There are some examples. I've not typed it. It's just handwritten. I don't know. Maybe what I will do is that I will scan it and send. Or if I can, I'll type it before afternoon so that we'll look at further examples from variance and standard deviation before we go into um linear regression, solving problems involving linear regression, and over factor analysis and all that. So this note I'm going to send to you so that you go through the second example. Then I'm going to send, what do they call it now? I'm going to send this solving to you so that you follow through. So any question from this example, let me go back there so that if you are stuck, you ask how to find mean and standard deviation. Variance is the square root of the standard deviation. So we say the standard deviation of score is 16.2, while the variance is 263.5. Once you find the variance, if you take the square root of the variance, you get the standard deviation. Is that okay?
Yes, sir.
Who is talking now?
I got you, sir.
Madam Agatha Chukuma.
Yes, sir.
Any problem?
No, sir. I was just saying that I understand.
You know this one, you said something that interests me, that you are putting yourself together. By the time you land, you know that somebody has come.
It doesn't follow, sir.
No, you say, but
I
you are
didn't.
putting, you say you are
I
putting your
didn't.
questions together. By the time
Oh
you
no.
strike,
No.
I will know
Why
that.
will I strike? I
No,
didn't follow
you strike
yesterday's
with your
class.
questions now.
Not really,
Because when
sir.
I say, do you have any questions? They say, no, you are putting yourself together.
Yeah,
By the
because I
time you
really
come,
didn't understand. I didn't understand yesterday, so I needed to go and look at it again so that I don't ask foolish questions. I need to look at it and
no,
know
you
when
can't
it.
ask foolish questions in the class, man. You can't ask foolish questions.
I
There's no
wasn't
question
following,
that
so
is
I
a
needed
foolish
to
question,
know.
no.
Okay, sir, if you say so.
So let's look at data collection. So methods of data collection, sources of data collection. Have we done this? I don't think so.
No, we have not done it, Doctor.
No, sir, we
So
haven't.
data collection. Data collection is the process of gathering and measuring information on variables of interest in an established systematic fashion that enables one to answer stated research questions, test your hypothesis, and evaluate the outcomes. So if I ask you what is data collection, this is what you're going to tell me. You will tell me there is a process of gathering and measuring information on variables of interest in an established systematic fashion to enable you answer stated research question, test hypothesis, and evaluate the outcomes of that your data collection. So data collection is a very vital component of research in all fields you can think of. Data collection is very, very critical. Even those people that read English, now you see their thesis have some tables. if it's a survey of novels, you see them take this data, survey of this class of novels, they will say 2, this one 3, 4. Which is the most widely read? They will analyze it. It's data they are collecting so that they achieve what they want to achieve. For us, for you in sustainability, you can't work without data. You collect data. By the time you start doing your project, you observe that at some point you will need to collect data. Maybe where you did your internship, you have to get data to come and fit in. Those of you who will be developing models, you develop a model, and you get data. Use this data to validate your model. The graphical profile of that model will give it a physical interpretation that the people right there on the field, the people who are not experts in that area, will see sense, will see reasons why your research is useful. So data collection is very, very critical. Those days that places to collect data were not there, people were having challenges conducting a research because you conduct a research, but you wouldn't get where to get data. But today, we have many places, whether on the internet, primary sources, you can get data there and use. So, sources of data collection. We have basically 2 sources of data collection. We have the primary data and secondary data. For the primary data, we have observation method, we have questionnaire method, we have interviews method, we have schedule method, we have case study method, we have survey method. Observation method. I don't know that it's in this class. I told you about those people in animal farm. If, for instance, you have some rabbits, maybe you have like 5 rabbits that you kept there. Maybe they are like maybe those rabbits are like let's say 3 weeks old. So every day or maybe every 2 days you are giving them enough food. So every 2 days you are going there to take the data on their weight. Maybe today you go, the rabbits are 2 kg. Maybe after 2 days or after 3 days, depending on how you arrange it, or your supervisor asks you to do. Maybe after 3 days you went, the weights are 4 kg. After another 3 days, 6 kg. After another 3 days, 8 kg. After another 3 days, 10 kg. You are getting those kg by observation. You stay and observe. In fact, the function you are going to come up with, I've taught you something about function. The function you are going to come up with will be y is equal to 2x. Y is equal to 2x. Why 2x? Because you observe that the kgs of animals are increasing times 2 is by 2, 2, 2, 2. So the data you are collecting there is based on observation. You are observing. So that's observational method. You are getting the primary data from an observational method. Now, questionnaire method. Questionnaire method, you design some questionnaires. Maybe you want to know how the performance of mathematics looked like in 2025 WAEC. You design questionnaires, you go to zone A, zone B, zone C. So in those questionnaires, the answers you get them directly from those schools. So that's the questionnaire approach to getting the primary data. Interview method is all this one-on-one method. You interview somebody How is the performance like? You're interacting one-on-one. It's not questionnaire. Questionnaire, you don't need to interact with the person. You just give them and go away. Once they finish answering, you come and collect your question. It's primary source. Interview method. Schedule method. You schedule with the establishment or the organization concerned. You go there. In this case, since you've scheduled, you go there, you interact with them and get whatever you want to get. Then you come back. A case study. We call it case study. The performance of mathematics in Benue State, a case study of Kilegado College, Makurdi. You want to look at the performance of mathematics in Benue State, but your particular focus is on Kilegado College, Makurdi. Why survey method? Although the explanations are done, we're still going to come to them. Survey method, you carry out a survey. You have research assistant who will go out to help you carry out the survey. So for secondary data, this data you collect here, some will be analyzed and published in books, in journals, in magazines, in literatures. Anything you read from journals, the data you get from journals, from literature, they publish data you get from journals, literature, magazines. These are secondary source of data. So let's look at them one by one. Oh, I don't have light and my battery is going down. 27%. After here, I have to look for a place to charge this laptop so that we can have an afternoon class. Primary data. Data that has been collected from first-hand experience, known as primary data. Primary data has not been published yet and is more reliable, authentic, and objective. So primary data has not been changed or altered by human beings. Therefore, its validity is greater than secondary data. Yes, because it's from primary data that you publish it in journals, in books, in magazines, in monographs, textbooks. So, in a statistical survey, it's necessary to get information from primary sources and work on primary data. For example, the statistical record of a female population in a country cannot be based on newspaper, magazine, and other printed sources. A research can be conducted without secondary data, but a research based on only secondary data is least reliable and may have biases because secondary data has already been manipulated by human beings. One of such sources is old, and secondly, they contain limited information, as well as they can be misleading and biased. So sources of primary data are limited, and at times it becomes difficult to obtain data from primary sources because of either scarcity of population or lack of population. Following are some of the primary sources of data. Now, you see this thing, this lack of population. I give you an instance. If you go to some ministries that they should give you data, they will not want to give you. Because I don't know what they are hiding. That is why at times we give notes from the university, our students who want to get data from State Bureau of Statistics or Federal Ministry, National Bureau of Statistics. We give, what do they call it now? We give that this person is a student, is a PGD student in the Department of Environmental Sustainability and needs data to validate the works he's carrying out in the department. So kindly give him cooperation and attend to him as desired. At times, because they know what they are doing with that data. Somebody recently told me that because they were passing with this grass cutter, I said, me, I'm not interested in buying. The guy said, why am I fooling myself like this? So that means if I see rat self, I will not eat. I say, Lassa fever is available everywhere. Say, these people are fooling us. They want to get money from federal government. That's why they say Lassa fever is everywhere so that they can give them funds. I say, what? That's what the young man told me. Oh. He said there's no truth in that. If I want to eat grass cutter, I should eat grass cutter. So that means the data, if it's true, what he's saying is true, the data I will get from that place will not be reliable because they are faking it to get funds from, you know. So that's why they said here, sources of primary data are limited and at times becomes difficult to obtain from primary source because either scarcity of population or lack of cooperation. So the observational method. My laptop is going down. The observational method is the most commonly used method, especially in studies relating to behavioral sciences. Observation becomes a scientific tool and a method of data collection for the researcher when it serves as formulated research purposes. It's systematically planned and recorded and is subject to checks and control on validity and reliability. Just like I told you, it's a systematic approach. You observe, you go to the field, just like the example I gave you, you observe the rabbit, you take the cages, just the weight, you know. It's very, very common, especially those guys in fact, the big agri students. This is the method they use more because they go to the field, observe what is happening there, and record. So that is observational method. Now, use of observational method. There are a variety of reasons. There are a variety of reasons for collecting observational data. Some of these reasons include when the nature of the research question to be answered is focused on answering a how or what type question. So, when the topic is relatively unexplored and little is known to explain the behavior of people in a particular setting, observational method is used. Two, when understanding the meaning of a setting in a detailed way is valuable. Three, when it is important to study a phenomenon in its natural setting, then this method is deployed. For the classification, there are basically two types: participant and non-participant observation. Participation by the observers with the various types of operations of the group under study refers to participant type of observation. So, but in the non-participant type of observation, no participation of the observer in the activity of the group takes place, and also there occurs no relationship between the researcher and the group. So these are by the time you read on your own, you will know in details the difference between the participant observation and the non-participant. Participant, you have to be there to take this data, but the non-participant, you mustn't be there. Even an instance, you can use the attendant in the animal farm to help you take data. You mustn't go there yourself, but it's good that when you are carrying out your research, you participate in that research so that you know how the trend of your data collection is moving. Others, non-participants, we'll just go there and just tell them that, please, coming here early in the morning to come and take data will be a challenge for me. So just help me take the data. You're not participating, but the result is coming. And if the person does it very well, it's very, very reliable. So questionnaire method, I've already explained the questionnaire approach. You just design some test instruments, research instruments, you distribute to people. When COVID came, people were filling out questionnaire and surveys using questionnaire. Have you heard about COVID? If yes, you put yes. If you've not heard, you put no, like that. So, questionnaire approach, many persons use it, especially those in the humanities, in education. They use the questionnaire approach very, very well. It's also a very good primary source of collecting data. These are the basic rules of the construct. Interview method. Interviewing involves asking questions and getting answers from participants in a study. Interviewing has a variety of forms, including individual, face-to-face interview, face-to-face group interviewing, and the asking and answering of questions can be mediated by the phone or other electronic devices, e.g. computer. The way we are talking like this, if I want to get some information from you, I can ask you from here. So the interviews can be, under the interview approach method of collecting data, the interview can be personal interview, that's one-on-one interviewing. It could be telephone interview where somebody will be in Kano, you want to get an information. You said you just saw on the television that there's an accident on the Otedola Bridge. So can you give me a brief on-the-spot assessment of what is currently ongoing at the Otedola Bridge? And the person will give. That's the telephone interview of getting your information. And the schedule type of data collection, this method of data collection is very much like the collection of data through questionnaire, with little difference, which lies in the fact that schedule are being fed by the enumerators who specially appointed for the purpose. Just like I was telling you earlier on, it's the same thing like this questionnaire interview, but in this case, it's scheduled. It's scheduled. Questionnaire, you mustn't give anybody notice that you are coming. You just, as you are going around, you just give people and go. But in the schedule method, you will come the first day, tell the school that you are coming to give some questionnaires. You're coming to get some information from the school. So you want to book an appointment so that everybody will be available. In this case, you are scheduling. Questionnaire you mustn't schedule. As I'm going, I can be giving if I just see you on the way, please help me fill this. Oh, say, no, I don't have time. You didn't tell me before now. You'll be going. As you are going, some persons will be available to fill the form for you. You fill and go. So, but for the schedule, you make an appointment, then you schedule, and the result is gotten. So there's a difference between questionnaires and schedule. Both questionnaire and schedule are popularly used methods for collecting data in research survey. There's much resemblance in the nature of these two methods, and this fact has made many people to remark that from a practical point of view, the two methods can be taken as the same, but the technical point of view difference between them. But from the technical point of view, there's difference between them. The two important differences are as follows. The questionnaire is generally sent through mails to informants to be answered as specified in the covering letter, but otherwise without further assistance from the sender. The schedule is generally filled out by the research worker or the enumerator who can interpret questions when necessary. My laptop is about dying. It's 5% now. But you read all that on your own. Then the case study method. The case study, as I was explaining earlier, is an in-depth investigation of a single person, group, event, or community. Typically, data are gathered from a variety of sources and by using several different methods, e.g., observation and interviews. So, managing health system, a case study of Federal Medical Center, Makurdi. That's a case study. In this type of approach, you are taking an in-depth time to look at what transpires at the FMC. If you say managing patients' attendance by medical doctors, case study of teaching hospital, that means your research will be focused in teaching hospital. You take an in-depth study on how medical doctors manage the, coming in of patients. As patients are coming, are they giving attention promptly? Are they not giving attention promptly? So an in-depth study will be carried out. When you are there, you get all the various the various data you want to collect from there, because you have to use the participants that are coming, the patients. Since you came, when did you come to the hospital today? I came around 8 and I've been attended to. You note it down. You go to another section, you will have E&M, you have surgery, you have pathologists, community health. You go to each of the departments. There will be patients that you ask them, since you came, have you been attended to? Some will say, no, since I came, I've not been attended to. So you note all those things down, so that at the end of the day, you carry out an in-depth analysis, draw a variable conclusion. It's based on this conclusion that the outcome of your research, the management of the hospital, that either you are commending them or you will say, this is the outcome of our research, and the outcome of our research shows that under your leadership, you are not doing enough. So your research is saying that patients are not being attended to very well. So you need to improve upon the way doctors and your health personnel attend to patients that are coming to get healthcare delivery. So under the secondary source of data collection, we say that secondary data is the data that is collected from the primary sources, which can be used in the current research study. Collecting secondary data often takes considerably less time than collecting from primary data, where you would have to gather every information from the scratch. It's therefore possible to gather more data this way. It therefore possible to gather data more this way. So secondary data can be obtained from two different strands, one quantitative and qualitative. The quantitative approach will involve census, housing, social security, as well as electoral statistics and other related databases, while qualitative is semi-structured and structured interview, focus group, transcripts, field notes, observation records, and other personal and related research-related documents. So, secondary data is often readily available because when you go to websites, you will see, like NCDC, you see several data there about those records about COVID, records about Lassa fever, records about HIV. When you go to the website of Nigerian Center for Disease Prevention and Control. You see all those data there. So, but people have really taken time. Before though you saw all those data on the website, researchers, research assistants have taken time to go to hospitals to take this data, and they now come down, put the data together. As the data collection is going on in Benin, is going on in Lagos, Kaduna, Birnin KB, in Ogun, they put it together and put it on the website. So you going to access the data on the website is secondary source you are using to get that data. So that's why we say secondary data is often more available than the primary data. Primary data it is time consuming, and you spend a lot of resources, because if you want to collect data based on Lassa fever now that is giving us health concern in Nigeria, particularly Benue now. If you go to teaching hospital, you have to mask yourself very well. You have to be in a protective distance to take the data. You ask how many persons are affected. You go to Boko, you go to Tupo, you go to Obadibu. You'll be asking in the health centers how many persons have been affected. They will tell you, you record, and you come and sit down, put everything together and put it on the website. So you are getting the information firsthand as the primary source. By the time you refine this data, sum everything according to local government by local government in Benue State and put it on the website, once a secondary source data collection. If I go to the website and get it, I'm getting the data from a secondary source, not a primary source, because I did not actually go to the field. So from my ends, that's how far we can go for this morning session. So this notes too, when I charge my laptop, I will put it on the platform. Before the afternoon session, I'll put it on the platform. Any question based on what we have just done now? Oche?
Hello, sir. I'm here, sir.
Yes. Mariam Abdulkadir.
Yes, sir. Good morning, sir.
I think
No
as
question,
time
sir.
progresses, I'll be seeing you post faces, so because maybe I'm just thinking some persons used to just on this what do they call it? On the Zoom, and they'll just drop it and go their way.
Go and check it very well. Hello,
No, sir. I've been following.
Oga Oche, I've seen your face.
Okay, hello, sir. Please, sir. Hello, sir.
Yes, sir.
Please, I want to appeal to you, sir.
Happy.
I want to beg that I can submit this assignment tomorrow. I want to appeal whether I could submit this assignment tomorrow. My gadget is going down. I need to charge. I haven't had light since yesterday. I'm just managing it. So I did the assignment and I got stuck on the way. Please, sir.
It's okay.
Okay, sir. Thank you, sir.
Noted. You can submit tomorrow.
Okay,
So
sir.
I'm so happy.
Who is talking? Is it Oche?
No, I'm just the one that spoke now. I've just finished. I'm the one that finished speaking to you.
Okay.
Yes, sir.
With my phone.
Okay. Balogun. Hello, sir. Is Bankole here?
Yes, sir. Yes, sir.
Is it the bank? Is it the Bankole I met last week? Online?
Online, yes, sir, it's the same bank college, sir, but we didn't talk, sir. That's if we spoke. Hello, sir.
Yes.
Yes, sir. I'm online, sir.
Okay. So, see you in the afternoon.
Yes, sir.
So we are supposed to submit the assignment in the afternoon, right?
Somebody just appeared that is having challenge with electricity, so I should allow him submit by tomorrow. So since I'm allowing to submit by tomorrow, those of you who have not submitted, I think I've got like 9 or 10 submissions. So the rest of you can submit tomorrow.
All right, sir. Thank you so much for that understanding.
Yes, sir.
You are welcome. So see you guys in the afternoon.
Bye.
Okay, sir.